everybody, today we're going to look at binomial distributions in Minitab. Before we go to Minitab, let's talk about what a binomial distribution is. When we're dealing with the binomial distribution, it's important that we have a fixed number of trials. In each of those trials, the probability of success stays the same, and there are only two outcomes that you can have, a success or a failure. Experiments that have just two outcomes are called Bernoulli trials. Another important characteristic of binomial distributions is that each trial in a binomial distribution is an independent outcome, meaning the results of a previous outcome don't affect the next outcomes or vice versa. And even though binomial distributions have these common characteristics, it doesn't mean that the shape of the distribution is going to remain the same. It could be skewed right, skewed left, or symmetric depending on the number of trials and the probability of success. For our first example, let's consider a student that's faced with a 10 multiple choice question test. Each of the questions has 5 possible answers to choose from. This means the probability of guessing one answer correctly is 1 in 5 or 20%. The probability of guessing one answer incorrectly is calculated as 4 in 5 or 80%. There's one right answer and 4 wrong answers for each question. Let's think about the number of ways a student could guess 9 questions correctly. Let's start by letting S represent a success. That means the student got the question right. And we'll let F be a failure, meaning the student got the question wrong. In this situation, we just need to think about which question did the student get wrong. Did they get the last one wrong, the first one wrong, the one in the middle wrong? Because we're looking for one wrong answer out of 10 possible questions, it means there are 10 ways the student could guess 9 out of 10 questions correctly. But don't be fooled by the 10 ways the student could get 9 questions right. We need to consider how many ways the student could guess on the test altogether. Since each question is independent, the number of outcomes in the sample space is 5 times 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 5. That's 5 to the 10th, or 9,765,625 ways to answer the test. When we go back to the probability of getting exactly 9 right, that would be 10 over 9,765,625, which is a very small number. The formula for binomial probability is the combination of n choose x, p to the x, times 1 minus p to the n minus x. N is the number of trials, x is the number of successes, p is the probability of success. This formula helps determine the probability of achieving exactly x successes in n trials, which is crucial in statistics, but it's also complicated to figure out. The good news is that technology can help. I'm going to show you how to find binomial probabilities in Minitab. I'm going to start with this example. Consider playing a game in which you have a 15% chance of winning. If you play the game 8 times, find the following. We're going to look for the probability that x is 3, x is greater than or equal to 5, and x is greater than or equal to 3 and less than or equal to 6. In Minitab, I start by going to Graph, Probability Distribution Plot, View Probability. In the distribution, I'm looking for binomial. It asks for the number of trials, which we said was 8, and the probability of success, which was 0.15. We're going to click on the options. This time we're looking at a specified x value. Because we're looking for the value of x being equal to 3, I'm going to hit the middle and I'm going to say both values are 3. This will give us our binomial probability distribution graph. You can click on the graph to see other values of the binomial probability distribution. Because we wanted the probability that x is equal to 3, it's highlighted the 3 and given us the value 0.08386. We'll write that as 0.084. Now let's find the probability that x is greater than or equal to 5. Back in Minitab, I'll select Graph, Probability Distribution Plot, View Probability. I'm going to change my options to be right tail because I want the x value to be greater than or equal to 5. This gives us a value of 0.002854. I'll round that up to 0.003. Next, we'll find the probability that x is greater than or equal to 3 and less than or equal to 6. So again, graph, probability distribution plot, view probability. On the options, change to middle. We're going to go from 3 to 6. This says our probability is 0.1052, which I rounded to 0.105. Let's do one more example, and in this one, I want you to really pay attention to the wording. A pharmaceutical company claims a new allergy medicine is effective for 80% of patients. To test the claim, a hospital selects a random sample of 15 patients who take the medicine. X is going to be the number of patients out of 15 for whom the medicine is effective. Our first question says, what's the probability that at least 13 patients find the medicine effective? At least means 13 or more. We write that as the probability that x is greater than or equal to 13. Back in Minitab, we hit Graph, Probability Distribution Plot, View Probability. We need to change the number of trials to 15 and the probability of success to 0.80. On the options, we want to go right because we want greater than or equal to 13, which gives us a probability of 0.3980. Next, we'll find the probability that at most 10 patients find the medicine effective. At most says we stop at 10. This is the probability that x is less than or equal to 10. So when we go back to our plot, we'll change the option to go to the left, and we'll change our x value to 10. This gives us a total of 0.1642. Notice in these situations, with greater than or less than, Minitab is adding up the columns so we're not having to find the probability of 10, 9, 8, 7, all the way down to 0. It gives us the cumulative sum of all the probabilities. We'll finish by finding the probability that exactly 12 patients find the medicine effective. You have two choices of what you can do. We can go through the steps of graph and plot and changing the options, or you can click directly on the graph and find the probability that x is equal to 12. This says it's 0.250139, which I rounded to 0.25. But if you prefer to go through the steps, you can hit graph, probability distribution, view probability. On the options, go to middle and put in 12 for both values of x. This will isolate the single column where the outcome is 12 successes, and it still gives us the value of 0.2501.